Welcome to the Regenaissance Podcast. I'm your host, Ryan Griggs. Visit www.theregenaissance.co to learn more.
Hello, everyone. My name is Ryan Griggs. I'm the host of the Regenaissance Podcast. Today, alongside me, I have Mark Easter. Thank you for joining me.
Great to be here, Ryan. Thanks.
So to get started, for the listeners, because I've typically in the past have been talking to farmers and ranchers, but the great thing with this, there's so much that goes into the food system, and there's just so many different avenues to take. And with you in particular, having a book that's coming out called The Blueprint, A Food Lover's Guide to Climate Chaos, which sounds really interesting, and just wanted to talk a little bit about the couple of the chapters just before diving into it. For the very first chapter, the excited skin of the planet, then the unnatural green of desert vegetables, the salmon forests, the corn eaters, Steve's peaches, the cow in the room, Cecil's hands, the Feast of Legions, and then the blue plate. So even just hearing that, it sounds very exciting and covers a lot. So I guess to get started, yeah, if you could just tell me a little bit about yourself and what led you to writing this book.
Sure. Yeah, and thank you for that. And love being on your show here. Yeah, so I'm a greenhouse gas accountant. I'm an ecologist by training, but I worked at Colorado State University for a little over 30 years. Still affiliated with the university, but I partially retired a little while ago. And I worked in a research team that we were studying. The short version of it is the carbon footprint of food. We're trying to understand what the greenhouse gas emissions were that were produced by growing, processing, shipping food, cooking it, and then dealing with the leftovers. And that was a long road. It started in the early 1990s, with the Earth Summit, where the nations of the world decided to, they agreed to report the carbon emissions to each other and try to do it in a way that was consistent and transparent. And one of the things that the scientific community pointed out and the world quickly realized is that whereas we're starting to get a handle on, at the time, what the carbon emissions were from burning fossil fuels, there were big gaps in the scientific understanding about how emissions came from growing food, and in particular, emissions from the soil. We found out that there were large nitrous oxide trace gas emissions that come from the soil, methane in some cases where rice is grown, but also carbon dioxide, and it was associated with how we grew crops and how we managed the soil. But what we've discovered over time is that there were actually great opportunities to reduce those carbon emissions and return carbon, draw it down from the atmosphere back into the soil through changes the way we grew crops. There are also big scientific gaps in other places, like understanding enteric methane. That's the famous cow belches, the methane that comes from the guts of cows, and methane from manure lagoons and other ways that manure gets stored in confined animal feeding operations, and the way manure gets used, and other sources of emissions like emissions from landfills associated with food waste. I'm trying to understand what those emissions were, but also how could they be reduced, and were there a way to leverage those resources in a way differently? Stop treating them as waste, use them as actual resources in a way that actually contributed to climate solutions and soil health and soil fertility overall. So the book was really my attempt to try to contribute to the public conversation about greenhouse gas emissions from the food system. And we realized at the time, whereas the scientific community was really talking to each other a lot, we had having very intense conversations within the IPCC working groups and outside as well. There wasn't really a good, solid effort to try to communicate these types of emissions to the public. And so this was my effort to try to do that.
So through that then, because with regenerative agriculture definitely picking up a lot of steam, especially on social media, and then the whole world of the plant-based movement, there's just so much that's thrown out there, and then especially in talks relations to climate change. Whenever you're doing all this research and whatnot, especially with the folks that you said, the you said an acronym that I've never heard of.
Sorry, the IPCC, the Intergovernmental Panel on Climate Change.
So I'm curious with like that world, how involved are they with actual farmers and ranchers? Because that's been something that I see from time to time too, from just talking to people in person and seeing it online is whenever I see critiques towards farmers and ranchers for the work they're doing, it's very easy for me to see through a lot of their, I'm not going to say lies, I'm trying to figure out the best way to phrase it. A lot of the folks that critique these people, the farmers and ranchers, have never visited one or even worked on one. And so I'd just love to hear the landscape of the land for that world, because that's always been my challenge, personally. And so I try to come at it at a neutral lens with all of this, because it's a very hot topic, very polarizing topic as well.
Yeah. Yeah, that's a great perspective, and I'm really glad you asked that question. And that was really why I wrote the book the way I did. The book is really telling the stories of the growers, ranchers, farmers, other types of producers, and also scientists and extension specialists and other people that are working closely with them around the efforts that are out there to rewrite the story of food, specifically focused on regenerative agriculture. And so I'm working with people that I consider to be the heroes of the regen ag movement, people who have gone all in with carbon farming, and they found it to be just a win-win for them. They firstly, all of them talk about it as a no-regret strategy for their operations. And it's a really good point. And there is the potential for a divide between the research community and the farming community. And what I think is so fascinating about this is that consistently we see the farmers and ranchers are actually starting to drive the research. That's been going on for quite a while now. And one of the growers I profile in the book, the chapter, The Excited Skin of the Planet, it's about soil carbon and bread and really production of grains. And the grower is named Curtis Sales. He lives and farms out near Siebert, Colorado. He and his son-in-law and their respective families partner up. They grow on a little over 2,000 acres of, it's all dryland farming out there. Curtis and Steve Tucker from Benongo, Nebraska, and other farmers in the area there, they basically formed a cohort. And they said, we want to figure out how to do regen farming on dry land. We need help. And they went to Colorado State University and said, hey, can you help us? And CSU responded. And they worked with a research scientist there named Dr. Megan Shapansky. And they put together a research proposal. Working together, they got the funding to implement this work. And so the growers drove the questions. They defined, this is what we need to know. This is where our barriers are. And then they worked together to design the experiments, and folks at CSU helped with the statistical analysis. But the actual experiments, the research was done on the growers' farms themselves. I think that's just such an exciting model because that sort of active practice-based research is really what's needed in regen, because they're, farmers and ranchers, they're just some of the most innovative people on the planet in terms of, the work that they're doing. And you can't help but see, if you spend any time with them at all, you see the level of experimentation that's going on, on a field by field basis, grower by grower basis. It's fascinating.
Absolutely agree. That's kind of why I brought up that point too, is my critique with the folks that can be very outspoken but yet have never visited a farm. That's why I said that, just because working on a farm and just seeing how they operate, and then take Joe Salatin, for example. If you put him on a piece of land and just hear him, how he talks about that piece of land would blow your mind. And that's why it's really cool with this book. So I'd be curious with that specific example of the grain farmer, how long was the research phase? Or yeah, I guess from the beginning to I guess the end of working together, what was that process like? How did you decide working with him too, at the start?
So Megan Shapansky at CSU connected me with Curtis, and so he and I had a series of dialogues. And just to be clear, Megan's relationship with Curtis and his cohort had been going on for years at that point, and it's still continuing today. And this was an opportunity for me as a colleague of Megan's to drop in and spend some time with Curtis and his family. And so I didn't play an active role in the research that they were doing. I just learned about it from Curtis and from Megan as well. But their program was going on for years, um, and so but the I through my work at CSU, I spent a lot of time working with the NRCS and with Extension Service at Colorado State and other state universities like Iowa State, Michigan State, Penn State, other places. And so and through that process, I've worked with literally hundreds of farmers around the US and hundreds more on other continents, um, trying to understand details around carbon farming, regenerative agriculture, the practices that these growers have implemented to try to increase the organic matter in the soil or reduce the emissions, try to use fertilizer more efficiently. Functionally, these are all things that they're trying to do to improve their bottom line, try to improve their soil, increase their resilience to weather variability, and these sorts of things. And all of those have benefits in terms of reducing greenhouse gas emissions beyond the resilience that they offer to the farmer.
My next question, just on the topic of just carbon too, because it seems like the main focus is always agriculture and more specifically animal agriculture. I'm trying to figure out how I can best phrase this. I guess, why do you think that is? Why does the last, I don't know, 3, 4 years, it just seems like that's the only focal point. And I always find it funny when, for example, say someone like Leo DiCaprio talks about climate change, but then he's just taking a private jet wherever he wants every single day if he wants to. So I guess, yeah, just from your opinion, why do you think the focus is always comes down to agriculture and animal agriculture?
Mm-hmm. Yeah, that's an interesting question, and it's people want to talk to me about animal ag and emissions associated with the meat system, and I think it's because frankly, what the scientific evidence shows is that emissions from enteric methane are large, and people have focused in on that. They've locked in on that. One of the things that I try to address in the book is explain what the source of that is, why that's the case, and what the barriers are to potentially reducing that. But then also talking about specifically what the role of animal agriculture in the ag system is, because it's not just beef animals being raised on confined animal feeding operations. It's not just dairy animals, living in barns, cranking out milk. Um, the the manure that they produce is a major part of not just organic agriculture, but agriculture in so many different places. And I mentioned at the start here, stop not no longer thinking about that as waste, but that is thinking about that as a resource. But going beyond that, starting to think about animals not necessarily as the endpoint for feedstocks, but tying them back into, integrating them back into cropping systems. What we're finding and this is again farmer-led research, producer-led research, as well as other academic studies, that when you bring livestock back onto, integrate them back into cropping systems, grazing down on feeding on corn stalks, for example, or wheat stubble or whatever, barley stubble, whatever it might be, but also having them graze down cover crops in the shoulder seasons. That doing that, it accelerates the process of increasing organic matter in the soil. And studies have shown that increases like on the range of 10 to 40%. That's 10 to 40% faster than if the livestock were not there, which I think is fascinating. The other thing that I profile one of the growers in the book, Dan DeSutter from Indiana. He's from West Central Indiana, south of West Lafayette. He's developed this system he calls the corn, soybean, cow rotation, where he's got cover crops growing in all of his shoulder seasons. And after his soybean rotation, he grows a cover crop that's specifically focused on forage for cattle. And his son operates the cattle operation. They come in and graze that down. And what they're finding is that by doing that sort of thing, first of all, they've added a third income stream to their operation, which is increasing their resilience to the ups and downs in the commodity market. But also, it's dramatically reduced the amount of inputs that they have to add back in for the corn crop that comes the year after that. And they're finding the organic matter is increasing, and they see a lot less of the ups and downs in terms of yields. Their yields have stabilized. They're consistently beating the county average and the yields of their neighbors who are not doing these sorts of practices. It's definitely more complicated for them, and that father-son team Dan describes as being essential for them for their success. But this is to just wrap back to your question about really agriculture and why so much focus on livestock. We see the role of livestock being integrated back into these systems. By doing that, you're reducing the need for ag chemicals. You're reducing the cost for the growers. You're also reducing the carbon footprint of the system as a whole, and that can be attributed straight back to the cattle. And so, despite the enteric emissions, which are hard to get around, hard to avoid, there's other contributions and it's not just cattle. You can do similar things with poultry and with sheep and other grazers. You can reduce the emissions of the operation as a whole and attribute that back to the cattle. And these are value added. This is a layer of benefits that goes beyond the CAFO model that has such high emissions associated with it now.
That was going to actually be my follow-up question, is specifically towards CAFOs. Going back to the beginning when you mentioned about the just massive methane emissions, from your research, were you able to find how much that comes from specifically CAFOs versus just say that farm in West Lafayette?
Yeah, it's a great question. It's really interesting. The majority of the emissions come from the cow-calf operation, leading up to the point where feeder stock, whether they're backgrounded or whatever process they go through before the calves end up within the CAFO. The majority of those
it's before that.
Yeah, and the emissions are largely associated with the cow-calf pair. Really, it's really interesting, and so that what's really interesting about this is once they get to the CAFO, the emissions pivot, leading up to the point where the cow-calf pair goes to the CAFO, or the calf from the cow-calf pair goes to the CAFO. The emissions are largely that enteric methane, the cow belches. Once they get to the CAFO, the emissions, you have those enteric emissions, but they tend to be smaller once they're at the CAFO because they're being fed a diet that's rich in grains and simple carbohydrates, so corn and some of the carbohydrates that come from soybeans, but also canola and other products. And so they tend to produce with less roughage in the diet, like they get when they're out on pasture. They produce less of that enteric emissions. But then you also have piled on when they're in the CAFO, the emissions from managing the CAFO, from producing the feed and the forage, and then bringing that shipping that to the CAFO, processing it there. And then in the end, regardless of whether they're raised in that kind of environment or grass-fed or in one of these integrated livestock cropping systems, like I discussed, you have the processing element of it. And that's relatively consistent across the board, whether it's coming from, however the cattle are raised up to market weight. The processing costs tend to be about the same.
So going back to the cow calf operation too, because that actually surprised me when you said that. If you could just shed light on that process, and especially how pertaining to emissions, yeah, how exactly is that more than the CAFO itself?
Yeah, it is a little bit surprising, isn't it? So what the research shows is that when you have a cow-calf pair out on pasture, so they're typically feeding on, during the growing season, they're going to be feeding on pasture, and it's typically a grass. It's whatever the producer is able to develop and sustain on their pasture, and it's typically a grass or a grass legume mix or some other mix of forbs along with the grasses. Excuse me. And that, and then in the winter, or other times when the cattle can't actually be out on pasture, they're going to be fed some type of a hay balance typically, and potentially some other supplements for the pregnant mothers to help them, grow the calves. And so the emissions from that, like on a day-to-day basis, typically tend to be higher than what you see in the CAFO, and it's because the forage is richer, it's higher in the undigestible carbohydrates or the roughage, essentially the the cellulose. These are the sorts of things that's the feed for the microbes that are in the rumen that drive the methane production. And where the methane really comes from, I think this is one of the most fascinating stories about this. Cattle and microbes have evolved a relationship that literally goes back to the dinosaurs. There's evidence that's turning up that what cows are doing in their rumen with the microbes, it's the same sort of thing that plant-eating dinosaurs were doing tens of millions of years ago. They're eating this forage, it goes into the rumen, and then the microbes, they sit there and they ruminate. And the microbes have their way with the forage. The microbes digest the forage down on behalf of the cows. And they get some benefits from that as well too. It's truly a symbiotic relationship. And then once that digestion process is done, the cattle start chewing their cud, and they start masticating, bringing the rumen contents back up. As this is not a new story to you and to the listeners of your podcast, and chewing it again, reprocessing it, and then they send it back down to the other part of the digestive tract. So the microbes are doing the initial part of the digestion, and it's that process, that microbe community in the rumen that's producing the methane. And the methane is coming because there's little to no oxygen in the rumen. And when the microbes gain access to these simple carbohydrates and the cellulose, and digest that, they're producing methane as a byproduct, not carbon dioxide. And that's why we have this source of methane coming from the cattle. And it's, again, it's a relationship that it's born out of a beneficial relationship between the cattle and the microbes. And it's hard to get around. There's a lot of discussion now. People are trying to find, are there feed amendments or additives that can be given? And there's some evidence that things like certain types of seaweed, algae, and other chemicals, when they're added to the feed, that could potentially reduce the methane emissions. But we're yet to see full life cycle herd level analyses with multiple herds around the country that go through the full life cycle of a beef animal or a dairy animal using those additives. So I think it's important that happens so that we fully understand what the potential impact on animal health, on food safety, on productivity, weight gain, milk production, those sorts of things at the animal or at the herd level in multiple sites. Once we see that, then I think we'll have a clearer understanding about how effective those additives could be.
Everything you just described just showcases how complex this all really is. Because on one side, you're mentioning with the emissions related to feeding them grain and whatnot versus grass, because it seems with the grain finished rather than finishing them on pasture, is there, from your research on the comparison of emissions?
Yeah, there is. There have been a number of comparisons around it. And what the findings show is that, and not just looking at greenhouse gas emissions, but looking at other sorts of things, the amount of land that's required for the two different systems, say, for example, also looking at things like issues with water pollution, air pollution, what's called acidification. When those systems are compared, there's basically no net difference between a grass finished animal and a CAFO finished animal. There is a difference in the amount of land required. When you look at strictly the CAFO model and the grass-based model, the grass-based model tends to require more land.
Yeah.
But when you look at air quality, water quality, and acidification, those all tend to be significantly worse with the CAFO model. What I think is interesting about this is that the life cycle studies looking at this integrated crop livestock systems have not been analyzed yet, and there's pretty significant. There's it's really in the realm of scientific speculation at this point, and so I just want to identify this as speculation, but that by doing that, we actually resolve some of the issues related to greenhouse gas emissions and the amount of land required. And it's likely that the land base required would actually potentially reduce to below both the strictly CAFO and strictly grass-fed model, and also that you can reduce greenhouse gas emissions for the system as a whole. And I think that's pretty exciting. I can't wait for the results of there's some studies that are ongoing right now, and really looking forward to see what we learn from that.
See, that's interesting too, because again, how we even got to CAFOs, I mean, just being transparent, it's extremely hard to get into agriculture, and doing that on a long-term scale, especially as technology was growing in America in the early 1900s to where we're at now. I mean, a lot of people that had their own farms and ranches would tell their next generation to try to get work into a bigger city, paired with the growing demand of just food and the growing population. So then the CAFOs, the turnaround time for cattle is quicker than grass-fed and finished. You can fatten them up quicker with grains, and then although they can eat grains, it's still not a complete natural diet for themselves. So grain finished is technically not healthier of a cow than it is for grass finished. But then there's just all kinds of trade-offs again with the complexity of this all, and that's why I like this conversation, because just so much goes into this. I mean, again, that's why I have this podcast. It's a very complex system. Outside looking in, it seems pretty straightforward. I mean, especially whenever you go in a grocery store and you expect everything to be there year round. It doesn't matter what food it is. We've grown accustomed to that. So I'm just curious then on the research itself. I guess, how do you go about that? What are there, like when you're building out I'm assuming you build out a research plan. Say for example, for this West Lafayette farm, how do you go about the research plan, and what are you actually, researching and studying, and then how long of a time period does that last?
Yeah, those are great questions. So to study soil carbon, it's really interesting to study how organic matter accumulates in soil or doesn't accumulate. to study how soil carbon changes in response to different practices like integrating cover crops or changing how you till the soil or adding manure or grazing livestock, those sorts of things. You typically need experiments that run at least 5 years and like 8 to 10 years or longer. And this is because soil carbon responds very slowly to these sorts of things. And there's so much variability in a field, or there can be so much variability in how a field responds. And so you have to take a lot of samples over a long period of time in order to do that. And so what we typically have to do is we have to design experiments that sample over time and sample from the same points over time. And we have enough samples in the field to account for the variability of the different soil types that might be present in the field. With other sorts of emissions, it's not just soil carbon and it's not just enteric methane from these sorts of things. There's other emissions. A significant one is the trace gas nitrous oxide, and it's the same gas that we get as an anesthetic in the dentist chair or certain types of surgery, depending on what it is. It has an extremely powerful climate warming effect. Like a single pound of nitrous oxide has about the same climate warming effect as about 300 pounds of carbon dioxide. So just a tiny bit of it goes a very long way. And there's almost no free lunch with nitrous oxide, we like to say. It's really hard to get around. The best practices are, because it comes from how fertilizer gets applied, when it gets applied, how much, we really encourage growers to focus on applying fertilizer to soil test, trying to split it up into as many applications as is economically feasible for them, and using the amount that's needed in order to get the outcome that you want, and ideally no more than that. And so studying these nitrous oxide emissions, it's extremely variable. It also requires expensive equipment, and you typically need to measure it on the same sort of sample rate that you do with soil carbon in terms of the number of samples. It tends to be very expensive. And it's also something that needs to be out on the field pretty much year round. With soil carbon samples, you can come in and you can collect a sample, once a year, say, for example. Or if you're interested in inter-year variability, you can come out and do it maybe once a month or once every quarter, although that gets to be very expensive. But with soil nitrous oxide, we can see that the emissions can come off the field all in a rush in the shoulder seasons. In the freeze-thaw cycle in the spring and in the fall is when typically somewhere between 60 and 80% of the emissions occur. And also right after fertilizer or livestock manure get applied or compost. And so, but there's still a lot of emissions that occur in between those events. And so you typically need to be sampling year round, ideally on a sub-weekly basis. So that tends to be expensive. Regarding emissions from, the enteric emissions from cattle, there's been a lot of different ways to try to go about measuring that. And you've probably seen the photos of the backpacks where the cows are wearing, the big balloon, and there's a horn that comes over and it's collecting gas that the cow might be belching out. There have been those. Other approaches that people are using is cattle are basically fed inside a sealed room for a week or so, or at least several days, and the gas balance inside the room is measured over time to understand how much methane they're producing, and so that tends to be the most effective approach in terms of trying to understand what the methane emissions are, but it doesn't necessarily capture the real world in-field conditions that we're seeing. And so there's a lot of different experimentation around trying to understand what those methane emissions are. But that's also something that needs to happen over a relatively long period of time. You don't want to leave, a cow or a calf or a cow-calf pair or a bull or whatever it might be. You don't necessarily want to leave them in a sealed room for weeks on end. You bring them in, you take measurements, you put them back out into their whatever their normal normal feeding system is, and then you bring them back in and you remeasure and put them back out. Then you come back and remeasure. So these are things that that take a lot of time, and I think it's absolutely fascinating work. And what we're learning from this is extraordinary. It just every time we we start peeling the layers of the onion of this work, we learn more and more questions get raised.
So I'm curious on just the topic of alternatives. So for me, for example, I was vegan for 2.5 years, and I was pretty convicted in my beliefs with that world. And then on the topic of lab grown meat and uh, just going plant based, and then that in tandem with nutrient density of food, because this is where my issue is with just the whole topic of animal agriculture, taking that away to implement more plant based. Say you have a plot of land to have as much nutrient dense food as cattle and other animals. My assumption is you need way more land because there's not, in the context of, say, protein, for example. I remember when I was vegan, I would get that question a lot. And it's a very valid question because there's not a lot of protein sources for vegans. It's heavy legumes and beans and nuts, a lot of tofu, and a lot of peas. That's pretty much all. There's not a whole lot of options. And then you talk about with agriculture for vegans too, can really, there's a lot of monocropping for that too, which destroys a lot of wildlife in itself. So that's why I have a tough time. To me, there's really not an alternative. We just have to be better with the systems that we have, a la regenerative agriculture, permaculture, and silvopastures and whatnot. I guess that's where I have trouble too with a lot of the critique of animal agriculture, because a piece of steak, the nutrition you can get from that, and comparing that to, say, a piece of tofu, it's just night and day difference. There's no comparison at all. And so I'm not sure where I'm going at with this. It's just, is there an alternative from your research, or I guess, how do you think we can move forward with the research that you've been doing? Because again, it's a very hot topic and polarizing right now. It has been for years and years. I mean, I know the government and social media definitely plays a part of that. But it's just, again, for me too, that's also why I preach going and visiting a farm and ranch. Because to me, a big piece of the puzzle that's missing is actually the connection to our food and our land. Yeah, is there a better alternative, or I'm just gonna leave it at that. Is there a better alternative?
Yeah. I think what you're getting at here, and I agree with you 100%, it's complex. I don't think it's just a cut and dried story. And there's a couple things that feed into that, and I'll try to be really succinct here. So if we're going to eat locally, if we're going to try to eat from our local food shed and support growers that live down the road from us or live within our watershed, something like that, some parts of the world, most of what can be grown safely and sustainably in that area is going to be plant-based. Other parts of the world, like where I live here in Colorado, a lot of it can't be plant-based. The only thing that you can really grow in any kind of sustainable model is going to be livestock, just because of the soils, the climate, the topography. It's too steep, it's too rocky, whatever. It would be just a disaster to try to grow wheat or tomatoes or or something else in a lot of the landscape where I live. And so where livestock fit in with other sorts of needs and other sorts of values, that's the choice that we're faced with. If we're going to grow food on the landscape in a lot of the world, it's going to have to be livestock. But we also have to balance that against other needs like issues, people raise with wildlife and um, with water quality concerns and stuff like that. It needs to be done well, just like with any kind of other agricultural system. Um, and as I said, it would be awfully hard to grow food um, in an organic model without livestock. The livestock manure is an important source of nutrients and organic matter for a lot of organic production. And also, livestock manure is an important feedstock for composting in a number of different operations. And so, but I think also as an ecologist, I think we have to remember that there aren't that every ecosystem has a grazer, and it could be a four-legged or six-legged or multi-legged. It could be um, cattle or sheep or elk or pronghorn or whatever it might be, all the way down to grasshoppers, and below that to whatever sort of members of the insect community are out there eating the plants, and they're pooping out manure just like the large four-legged versions are. They're just doing it in smaller quantities, but there's a lot more of them. And so that process of cycling from the grazing process, we have to recognize and take that into account, that it's part of the ecosystem, and the ecosystem functions differently. And we're starting to recognize it functions less efficiently in a lot of cases without having the livestock there. So I think that's part of the complication here. But I think the larger story is, though, that and this is described in a very comprehensive and highly readable paper report that I talk about in the book, called Grazed and Confused. And I'll say that again. It's called Grazed and Confused. And it came out of a research group in the European Union. And it's a fascinating look at worldwide meat production. And they ask a lot of these questions. And what their conclusion was, and I think they're right, is that we're probably at the point now where we can't sustain greater meat production, that the world can't consume or can't sustain an increase in meat production that's based on deforestation or converting more grasslands to cropland in order to feed in the CAFO model, that we have to make do with what we have right now. Because this is a part of the story that we haven't discussed here, but the process of deforesting land to create pasture for livestock, or grazing or plowing up existing grasslands, functioning working grasslands to grow corn and soybeans for a CAFO model, that leads to even more carbon emissions relative to trying to bring the livestock back onto the farm or other sorts of operations. And so as the human population continues to grow, we're either going to have to find ways to produce more methane or not more methane, more livestock on the existing land base, or look for other alternatives like lab-based meat, which
So
I haven't seen a good life cycle assessment that tells us what the carbon emissions are associated with that. And getting at that question you just asked, it's not lab-based meat is not you jump a bunch of algae into a vat of water and boom, you have to feed it something. And oftentimes that's soy protein and corn, fructose, and other sorts of carbohydrates that come from a farm somewhere. And how much land does that take?
another problem I have with this just whole conversation too is it's very hard. For example, with the deforestation aspect, it makes me think about why does America import so much beef from Brazil, New Zealand, Australia, so far away, um, when we have all the farmland we need to sustain and support all of the population, and then there's just so much litigation and laws and rules in place that make it very tough for farmers and ranchers. I mean, the bottleneck of processing in America is very challenging. So it's also my problem with the whole conversation too is they make it very challenging to where I don't want to get tinfoil hat on it all. It's just it's been very challenging to where for like the Grays and Confused from their research, does that play in a part of their research? Because it's just so hard to. I'm trying to figure out where I'm going with this. I mean, kind of going back to just the complexity of it all. With CAFOs, with all of the rules in place, because again, for the longest time, we've been able to sell beef in America labeled as made in the US whenever it was imported by Brazil, so far away. I mean, ranching in America, that's Texas Longhorn, Texas. I live in Texas. The cattle drives. We've had some of the best farmland in the world. I mean, the Great Plains era, grasses were literally as tall as horses back in the 1800s. It's just really hard for me to grasp a lot of these critiques whenever um, for like a best case scenario of what our agriculture could look like. Um, it's just very challenging with how we could go about it because I do not believe in lab meat at all. I to me, I believe in everything nature has already provided for us. It's just we have taken advantage of nature. I mean, deforestation is a great example. Um, and then there's just disastrous consequences. Thinking of the Dust Bowl, how that happened was just a lot of plowing and monocropping whenever the just massive migrations to the west for new farmers, uneducated farmers um, that just destroyed the land, and then nature responded in a horrific manner. We're essentially doing that again with our land. I'm going all over the place with this, but that's just why I always have a tough time with this conversation because there's so much that goes into it, and it's not black and white. And I truly believe we need more animals on land and more farmers and ranchers again. I mean, that's why I have this podcast and the brand is we don't have enough farmers and ranchers. But then there's also why is that is because it's hard for them to make a living. It's very stressful. The whole commodity market in America with soy and wheat puts a stranglehold on the farmers. And then if you want to be a chicken farmer, on previous podcasts I've had, he grew up on a massive CAFO style of uh, chickens working with a chicken plant, and those are essentially slaves to feudal lords. There's just so much that goes into this, and I know I'm just kind of going on a rant with here, but that's why I try to have these conversations because there is so much to more than what the eye sees in the world of agriculture with the climate and our food, nutrient density of it all. Um, yeah, so I was just going to end with that because I don't know where I was going to end with that.
It is complicated, and I think one of the things that um, I hear consistently from growers is that there's not a level playing field for them. They're subject to um, and without getting too much of the weeds on that, but it's a combination of market forces, a lack of diversity in the market forces, meaning there might only be one elevator or one beef buyer or sheep buyer or whatever to buy from, pig buyer. This what you're talking about, this system, the poultry production system in the country, it's very similar with pigs, and all the risk is put on the growers with no guarantees for. So you see the stories in the media right now. Growers take on millions of dollars in loans in order to build the facilities, and then the buyers that they're contracted to support pull the rug out from underneath them, step back and say, okay, we're either you're underperforming or our market base has shifted and we're no longer going to buy from you, and they're left holding the bag. It's really it's frustrating, I know, for a lot of growers. It's the same thing with the commodity crop systems. There's lots of similar sorts of concepts going on now. So navigating all that space, I agree, is challenging, and especially when you layer in um, greenhouse gas emissions on top of all of this. And that's one of the things that I really hope focus on in the book is really the hopeful side of regenerative ag, and in particular where we see when um, when price supports for, actually, that's the wrong word to use, when incentive payments are offered to growers in order to help them over the technological and capital costs of pivoting to a regenerative agricultural practice um, come into play. Growers respond to that. If they're able to get the $30 or $40 an acre for several years in order to help them integrate cover cropping, work through the risks the first few years, or pivot from intensive tillage to reduced tillage or a no tillage system, or bringing in the equipment for the fencing so that they can integrate livestock into when the capital costs, when people help with the capital costs, growers respond to that, and it helps a tremendous amount. And in the end, what I consistently hear from growers is once they get through that, the initial burden of the transition, the practices tend to stick. The adoption rate and the stick rate is well over 90% for most of these, and because the growers see it's lowered their costs in the long run, they're more resilient. Their fields are holding more water, capturing more water, and holding more water, making them less resilient to floods. All of these different things, and um, and layered in on top of all of that is a reduction in the greenhouse gas emissions from their operation that um, is so important right now. And I know that's not something that the growers are necessarily focused on unless they've bought into a carbon market, and they've contracted with somebody who's got a carbon market, or they're working directly with state or federal government through an incentive payment program that's tied to reductions in emissions. But there's so many of these side benefits that come in that hopefully will help growers weather all these other uncertainties and complications that come with the way agriculture is today. And hopefully the incentive programs that are out there and the other sort of technical support that's coming in here is something that can be integrated into, not layering additional complication on top of all the complications that people face today, but something that can be done that helps them to become more resilient and have more profitable and less complicated enterprises in the long run.
Do you have an example of a farm or ranch that was transitioning to regenerative agriculture and had that additional help?
Yes. I've worked with a lot of growers through the NRCS, and spoken with a lot of workers or a lot of growers who are taking direct price supports. Also, people who are involved in farmers markets. And I can only speak in the abstract because it's called personally identifiable information, and so my being involved with them, I have to basically agree not to disclose, their
Definitely,
specific details. Yeah, and I need to respect that. And
for
so,
sure.
but there are I've worked with dozens of examples of that. And I was just reading a paper last night that was looking at cover cropping, and the adoption of cover crop rates here in the U.S. remains relatively low. It's a little bit less than 10% of the total farm acreage has cover crops integrated. But it's growing. The rate it's growing is about 4 times what it was just like 15 years ago. So it's increasing significantly. And what this paper was describing, and this was a survey of I think 300 farmers, um, was that they responded very positively. There was a direct relationship between the amount of incentive funding and the technical support that the growers received and the adoption rate. So if adequate funding was there and they got either the technical support directly from the provider, from state or federal government, or a contractor, or more importantly, from their peer networks, other growers who are trying to do the same thing. So they're basically learning how to do it from each other. The growers were very enthusiastic with those sorts of things in place, um, and they were eager to do the integration. But without it, It's difficult to take on the risk because cover crop seed is expensive, and it adds a layer of complication that you may not be, as soon as your corn or soybeans are in, you may be ready for a break rather than, okay, now I got to get out there and I got to plant my cover crops or try to get them seeded, interseeded early, a month or two before harvest, and then dealing with the cover crop residue before you're trying to get out and plant, those sorts of things, or bringing in the livestock, those sorts of things. Maybe you've already got enough to deal with, especially if you're working a second job, to pay for the health insurance or put your kids through college, or those sorts of things.
Yeah, you bring up an amazing point as to just the whole world of talking about conventional agriculture and transitioning to regenerative agriculture. One thing I try to be good about, and that I hope most do too, it's very easy to talk negatively about conventional ag farmers and ranchers, just destroying the land, producing worse quality food, CAFOs, this or that. But then you think, I mean, if we're trying to bring people over to regenerative side of things, that's not going to work. And especially just trying to put yourself in their shoes, someone who's probably a third, fourth, fifth generational farmer, literally was raised on that farm. There's a wealth of knowledge passed down from, granddad and great great granddad, great granddad, and then father, etc. And then you've been doing the same thing for 50 years, and now all of a sudden you're being told everything you've been doing, you've got to change it. Not just that, the cost side of things, as you mentioned as well. And so that's why there needs to be a massive support, because there's obviously going to be people that are conventional farmers that are stuck in their ways and they don't give a rat's ass about what they're doing. I mean, there's going to be people like that everywhere you go. But then there's going to be a big set of people that, if they have the support and you're not just making them to be out a villain, they'll have an ear open to hearing what you've got. And I think that's the way to move forward. Is it's a collective effort, but then also it's very challenging from the producer side of things, because they'll hear this and that from the consumers, but it's not going to work unless you actually support these folks with your dollar. Because again, going back to visiting a farm or ranch, you don't realize how much goes into it all. Financial stress, the weather stress. There's just so many things that are completely out of their control that could literally wipe out their whole entire operation that they've sacrificed their whole lives towards. And then especially if they take the leap of trying to transition to regenerative agriculture, adding in cover cropping, that is a big deal. Because then that's also not making the promise that your first harvest after transitioning, or your first 2-3 harvests, are going to be successful. So you have to bear that as well, and think a big picture. So yeah, just to summarize that, the support is just crucial towards our farmers and ranchers. Because and there's just always trade-offs too. That's another thing I notice a lot of social media talks about. For example, I shared a video about a month and a half ago of Pasture Bird, the really large chicken operation in California. And they have these autonomous mobile coops that move 6,000 birds at a time. And it's just interesting. I mean, and it got a lot of traction. It's so many comments. And so I was reading through them, and it's interesting the comments people have for a lot of these folks, because they just expect them to have all the money in the world to do everything correctly, having all the work they need, because there's so much help that you need, and there's not enough people that want to help. So that's just a whole nother thing too. And then they just pick apart every little thing and just fully expect everything to go as planned. And why aren't you doing this? Why aren't you doing that? And it's very easy to be the critique sitting in the comfort of your own home. Probably you're watching through a laptop. So yeah, that's why I always say shake your rancher's hand, because there's just so much that goes into it all that you aren't fully aware of whatsoever. And that's not to say the farmers and ranchers don't know what they're getting themselves into. It's not like they're just doing that. I mean, a lot of them, that's their life. They love what they do. they want to support for their families and communities, and they just love being out in the land. But it's still, even though the trend and I guess the culture of agriculture is, to me, is really picking back up in America, it's still so much work to do with all of that, which is why I'm so passionate about it all, is because, like you said, they're some of the greatest people I've ever met in my life. I mean, I just visited the farm I worked on 2 years ago, about a month ago, and just seeing them with their kids, it's just so beautiful. And it gives me a lot of hope with everything. So I guess my last questions about the book too, just wrapping up the conversation. In your opinion, why should someone read this book?
Yeah, thank you. That's an awesome question. There's probably nothing more personal than food, I think, for each of us. And we come to any individual plate um, with carrying with us, the stories of our ancestors and the food that we've grown up with. We also come to meals with intention around. It might just be with our family. We might be alone for the night, or maybe we live alone. We might be coming to a meal to celebrate something or to seal a business deal, or maybe a friend is in crisis. And virtually every one of these situations, there's food and drink involved, and the food sort of brokers helps to broker the relationship. It's just something that's so important to us, and it's something we obviously think about every day. And there's such a strong connection between food and the growing climate crisis. The what I'll just call the food system, from soup to nuts, cradle to grave. You know, buying the equipment, the chemicals, farm chemicals that are used, buying the seed, planting the seed, going through all the operations, harvesting the crops, same sorts of things associated with livestock, and then shipping the products, and then processing it into food, and then dealing with the leftovers. All of that adds up to it's at least a quarter of the total human caused greenhouse gas emissions in the world today. And so we have this personal connection between food with this thing that is just so important to our daily lives and what's going on in the larger world in terms of the climate crisis. And what I think is so fascinating is through the work of my colleagues that I've just been so lucky and privileged to be a part of, and also all the farmers and ranchers I've worked with, is that the growers are showing it doesn't have to be that way. The emissions don't have to be so large from the food system. And additionally, the food system can actually be a major part of the solution. And in fact, it's been identified as one of the greatest opportunities to try to blunt the worst edges of the climate crisis. And that's to work with agriculture, to incent growers and leverage their skills and their access to the land in a way to grow food that's more nutritious, more resilient for them. It's going to be more profitable for them and lowers greenhouse gas emissions. And ideally, wherever we can, reverse those emissions back into the soil. Those are the stories that I try to tell through the Blue Plate. I'm really trying to focus on the heroes and the heroines in the food, in the agricultural industry, and what they're doing as templates for expanding it from the millions of acres where it's happening today to the hundreds of millions of acres and billions of acres we need worldwide to help resolve all of these different things that we've talked about.
I love that. My final question would be then, with just all the work that you've done with the book, I guess, do you have a favorite? What was your favorite thing from all your work that you leading up to where we're talking now? What has been your favorite, or maybe just one of your favorite things that you've experienced through all of this?
It was probably the opportunity to be with growers, and two specific examples being with Curtis Sales at his farm out near Seabrook, Colorado, and Dan DeSutter in West Central Indiana. Going out into their fields with a shovel and digging up a shovel full of soil, and seeing the health that was there, just seeing the abundance of, we couldn't see the microbes, but we could sure see the worms and
Yep.
all the other insects and the arthropods and everything else. They were just everywhere. And I'm not necessarily, I don't like to get into the blame game in the whole across the fence sort of stuff, but we did some across the fence sort of analysis, and it was stuff that was intentional. It was land that was being farmed without regenerative methods intentionally that these growers were practicing on. And we went in and dug the same shovelfuls of soil, and we didn't see any of that. And the soil smelled like a damp basement versus, the soil where the regen practices where it smelled fresh and citrusy, and it smelled like, the vegetable produce aisle in the grocery store. Is fascinating to
It's
see
a
that.
very it's a valid point, because the times that I've driven, out, I think this was West Texas, but then also just other places in America, driving around, and it just smells, all of a sudden just reeks of manure. And used to, I thought that was just normal. Now I'm realizing that's just from mismanagement, and that's just really interesting. And I agree with digging up the soil, because it also brings me up to my upbringing of seeing earthworms. I mean, I didn't think about it as much, but then when I worked on that farm in Pennsylvania, picking up a piece of soil, and they're just everywhere. And again, even just that little piece, it's just, I don't know. This is just why I love agriculture. It's just endless discovery and connection to this world that I've missed my whole life, and I know a lot of others too, whether they realize it or not. So thank you again for joining, Mark, and can use this opportunity to plug the book or anything else that you would want to do.
Yeah, Ryan, thank you so much. I really appreciate the invitation to join you here. And the book is The Blue Plate: A Food Lover's Guide to Climate Chaos. It's out from Patagonia Books. Um, and it's available either for order from Patagonia Books or other online vendors. It's also it's showing up. It was just released last week, and it's on bookstore shelves nationwide today. Just found it in my local bookstore here, which was um, just an amazing thing to just. I don't have a copy of it here right now. I'd show you, but it was amazing to just be able to walk in and pull it off the shelf and hold it in my hand and say, wow, all the years and all the effort associated with this. And the people at Patagonia Books have been terrific. And the designer, Christina Speed, and the illustrator I worked with, Liam O'Farrell, photo editor, Jane Sievert, and the editor at Patagonia, John Dutton, publisher Carla Olson. All of them have just, I don't think any author could have asked for more from a publisher. So it's been a real privilege to be able to try to pull that together. And again, I just say I'm really trying to focus on the people who are the heroes in the movement and not the villains. And so that's my intention. And hopefully the book presents that case well. And I so appreciate the opportunity to come on and talk with you today.
Yes, this is great. Thank you so much.
Visit www.theregenaissance.co to learn more.